So we've covered color as light and as pigment. We've covered hue contrast and intensity contrast. We've covered the properties of both the subtractive and the additive system, the subtractive being hue, value, and intensity, and the additive system being hue, luminance, and saturation. We have covered the idea of intensity contrast and atmospheric perspective and how intensity pops forward visually and neutrality sits backward. It has a receding motion. Now we are talking about value, which is the third property of the subtractive system and is one of the 7 color contrasts. Value is simply the perception of lightness or darkness of a color. It is not the same thing as brightness and dullness. So bright, dull, light, dark, those are different contrasts, different properties. A color can be light and bright and dull and light. So value refers to the lightness or darkness of a hue or a color. Value relationships are how we see form. We don't really need chroma to perceive form. If you look at a black and white photograph, you will understand that form is easily perceived, easily understood, and recognized just via light and dark, via value separations between different shapes. Color's not necessary. If you wake up early in the morning, before you turn the lights on, or before the sun comes up, you're not navigating via chromatic relationships, you're navigating via light-dark. So night vision is primarily light-dark. Value as a property in the subtractive system is the opposite or inverse to luminance, which is the idea in the additive system. So meaning it's inverse. If something is high luminance, it is low value. If something is low luminance, it's high value. So things that are on the lighter end of the value scale would be higher in luminance but lower in value. Things that are on the darker end of the value scale will be higher in value, lower in luminance. So less light is reflecting from the surface and more light's reflecting from the surface. One of the things that this directly relates to is print design. And when you are specifying paper and other types of substrates that will receive printing ink, one of the ways that you specify is via what is known as brightness, but it's actually the luminance level. Something that is higher luminance is going to be perceived as more white. And so you can have a paper that is reflecting at, say, an 89% luminance level or a 92% luminance level. And so something that would be considered a bright white might be an 89. Something more of a solar white would be 92 or 94. Something that's a natural white would be perceived maybe in the low 80s in terms of luminance levels. So that's how that directly relates. When you have values that are similar, so you have two different colors, whether they're bright dull or equal brightness or equal neutrality, side by side, if they're the same value or close to it, you're not going to be able to perceive the boundaries of those shapes as easily. When you have similar values, you get vague or what's known as lost boundaries. Value is generally expressed in a grayscale. And as you can see here, there is a grayscale going from white to black. We have white, we have our light grays, we have our middle grays, and we have our dark grays, and we have black. Every color and every hue has a value correspondent. So every color that we deal with has a assignment of lightness or darkness. When we talk about normal value, we're talking about the value of a spectral level color, meaning a hue. So we're talking about the value of hues on the hue circle before they are tinted, shaded, toned, and neutralized and create other colors. Normal value is the value of color at full intensity, and that would basically mean spectral or hue level. The top diagram, the hue circle, is showing all the chroma. That same circle has been converted to grayscale below, And so we see that yellow is the lightest of the hues at normal value. Violet is the darkest of the hues at normal value. When we get into red and red-orange and red-violet, we're starting to look at similar values if we look across the hue circle to their complements. Yellow is never as light as white. Violet is never as dark as black at normal value. To modify value, we can take the same steps that we took to modify intensity. If we're going to lighten it, we will add white or the perception of white. To darken, we will shade it by adding black. Here is a value scale using red, and we can see that saturation is out here on the right hand side, and then we have white, which is high luminance, 0% value, 100% luminance, and we're adding white incrementally to the red, and we are decreasing the red's value at the same time as we discussed last week. We're also decreasing its intensity. The value of the original red is a lot darker than the value of the white, by the way, so don't look at this as a value correspondent. The red actually will fit more into this range of gray. So this is a grayscale here on the left going from white to black and the various increments of gray between. And then we have the tones. All in here are the tones and the shades, and up top here we have the tints. So we can modify value through tinting, shading, and toning. And remember from our last discussion that toning, depending upon the value of the gray that you're adding in, will or will not modify the value of the color. Toning, tinting, and shading will always modify the intensity. This is a digital hue circle, and the normal value hues are actually halfway out toward the edge from the center, and they continue lightening with being tinted, and going toward the center they are shaded. So you can see within the red range you're getting into the pinks, you're getting into the burgundies. Within the blue range you're getting into the sky blues and then into the navy blues. One of the things about chromatic value, meaning value of a color, when you change it to black and white, you will immediately see the difference between the chromatic understanding and the achromatic. If there is detail in the chromatic that is the same value, those value differences will be lost when you change to grayscale, so you won't see quite as much detail. Like there's some very subtle variations here in the shadow of the jacket, which you don't pick up here because the values are similar. One of the things about chromatic value is that when you're printing, you have to consider the substrate, the paper that you're printing on. If you have an overall dark image and you're printing it on newsprint, it's going to lighten. If you're printing on something that is coded like Architectural Digest or National Geographic, it is going to be darker because all your inks are going to sit on top. So when you are adjusting for value, when you're doing print work, you need to adjust according to what you want to achieve in the final outcome, because different substrates are going to give you different results. Another thing to understand about value is just kind of like chroma, hue contrast. We see it in a relative state. It's always seen in relationship to. And so our perception of something's lightness or darkness may not be accurate without first understanding the surrounding color. So here we have a grayscale with a gray strip superimposed on top. And if you'll notice toward the left end, that gray strip appears dark on the lighter colors. And you notice on the right end that it looks light on the darker colors. The gray strip itself is not changing. It's the same gray. But we are perceiving a gradation from dark to light because the ground behind it is gradating from dark to light. And it's a very obvious inverse relationship. The lighter the ground, the darker the color will be perceived on it. The darker the ground, the lighter the color will be perceived. So that gray strip that's sitting there is the same color from end to end. It just appears to be lighter, and then it appears to be darker. We've already had a brief discussion about the idea of black, white, and gray being achromatic, meaning without chroma. A mid-value gray does not create an after image, it is entirely balanced. The after image of black is white, the after image of white is black. A mid-value gray has nowhere to go. It's totally in balance. You need no compensation for it. And that's why it's a really good idea to have a gray ground on your desktop display, because you will see colors accurately. If you're working in Photoshop or Illustrator and you've got a blue ground or some brightly colored wallpaper, you should change that to a mid-value gray. It will be much more restful for your eyes and will not cause you to perceive color incorrectly.